In this example, we are going to be talking about angular speed and linear speed. Angular speed is just your angle measurement divided by some sort of a time. So it could be degrees in a certain amount of time or radians in a certain amount of time. And they use a Greek symbol, sometimes known as omega, is what that kind of curvy W represents. And then linear speed is very, very similar to angular speed, except instead of a degree divided by time, you have a distance divided by time, because we're talking about a rate, right? So in our situation, we have the International Space Station orbits the Earth about every 90 minutes and is about 254 miles from Earth. Find the angular speed in degrees per second and the linear speed in miles per hour. So here's your degrees versus a distance. Of the International Space Station, Earth's diameter is about 7,917 and a half miles. So let's do angular speed first. All right, so for our angular speed, we are talking about, fancy W, is our degrees related to time. So we're making one revolution in 90 minutes. I don't care how far it is because it's not a distance. So it's a rough S. So we go 360 degrees in 90 minutes, but we wanted a degrees per second. So I'm just going to take that 360 to divide it by the 90. And it does go in nicely, actually. So the zeros will cancel. 36 divided by 9 is 4. So we have 4 degrees in 1 minute. But they want it in a degrees per second. So I'm going to take this 4 degrees 1 minute, and I'm going to convert it minutes to seconds. And 1 minute is 60 seconds, so the minutes will cancel, and we have 4 divided by 60. And if we throw that into a calculator, we got 4 divided by 60 is 0.0. Let's go 3 decimals. 1, 2, 6, 7 degrees per second. All right, so that's the International Space Station's speed in their angular speed. So anything, it doesn't matter how far or close to whatever orbit or wristwatch or whatever it is, if you're doing one revolution per minute, no matter what it is, you're going 0.067 degrees per second. So if we shift that now to linear speed, we're going to take a very, very similar approach, but it's a rate and it is a distance divided by a time rather than a degree divided by time or a radian divided by time. So our distance is we have one revolution, and that revolution is going to be a distance. So I don't need the degrees or the radians of it. I just need to know how many revolutions and how big one revolution is because I need a distance measurement. So we're talking about one circumference essentially is what's going on. So we have Earth, and then we have the International Space Station that is floating around. So we need to figure out that we need a circumference measurement on this. So our circumference is 2 pi times r, and our radius is half of that. So half of 7917.5 divided by 2. So there's our radius, and 3958.75. But then the International Space Station is out here going in that direction. So its path is going to be this bigger circle, which as part of the radius is this distance, but then we are going to be adding 254-ish miles to that. So plus 254. So the radius, so plus 254, That's the radius that we got going on. So 4212.75. So this is our circumference. One revolution is one circumference. If we were doing multiple circumferences, then I still would find the circumference measurement and then just times it by how many revolutions. It could be a fraction, it could be multiple revolutions, just depends on the situation. But 2 pi and then times our radius, 4212.75. Let's give it a label. In miles in 90 minutes. All right, so let's try to figure this out. And eventually I'm going to throw this all into the calculator, but not quite yet. I'm just going to do a little bit of cleanup. I'm going to take this value and multiply it by 2. So I'm going to take that and multiply it by the 2. So 8425.5. So we have our rate at 8425.5 pi, because we haven't multiplied that in anything yet, miles in 90 minutes. Okay, so that's great. Doesn't give me a very clear indication of what's going on, and we want miles per hour, not miles per minute. Well, right now we don't even have miles per minute. We have miles in 90 minutes. So we need to convert to miles per hour. So we're going to take that 8425.5 pi miles in 90 minutes. And I need my minutes to become hours. So I need my minutes to cancel and convert to hours. So we're looking at 60 minutes for 1 hour. That goes away. And then from here, I'm just throwing this into the calculator and see what kind of value we're going to get. So we're going to get, let's take our fraction. We're going to take 8425.5 pi over 90 times just a 60. So that is the speed at which the International Space Station, 17,646.326 miles per hour. So somewhere in the 17,000 miles per hour to keep it in orbit. So that is our miles per hour, and it's traveling at 0.067 degrees per second as well. So that was finding angular speed and linear speeds of the International Space Station.